Alright, so I've been showing you some applications of the ideal gas law, which is PV equals NKT. Now, let's put real numbers into the formula. So I wanted to show you an actual quantitative calculation using this. So it says, what is the volume of 1 mole of air at 0 degrees Celsius temperature, and it's going to be at room pressure. So we're going to write down what you're given and what you're looking for. So the pressure of 1 atmosphere, so the pressure that you're feeling right now, is approximately 1.01 times 10 to the 5th pascals. So you could look that up on the internet. So that is 1 atmosphere of pressure. Okay, then the temperature is going to be 0 degrees Celsius, but we need to convert that to Kelvin, because what would happen if you plugged 0 for the temperature here? What would you get? So 0 times anything is going to be equal to 0, and so the volume then would be 0. So this would say that as the temperature goes to 0 Celsius, the volume of the balloon would go to 0 volume. That doesn't make any sense, okay? But if instead of using degrees Celsius, we use Kelvin, remember absolute 0? So when you get to absolute 0 on the Kelvin scale, then the volume really does collapse to approximately 0 because the atoms are physically touching each other at that temperature. So remember, whenever you use this formula, you always have to use Kelvin for your temperature. And then, what is the number of air molecules inside the gas? Well, it said it was 1 mole of air. So capital N is going to be 1 mole of air, which is going to be 6.02 times 10 to the 23rd air molecules. So that's good to 3 significant figures. And then we're looking for the volume V. So we're going to take our equation here, PV equals NKT, and we plug all of those numbers in there and then solve it with your calculator. And I will let you do that, and it turns out that it's 0.0225 cubic meters. And remember that 1 cubic meter would be 1 meter by 1 meter by 1 meter. And that turns out to be 22.5 liters, where a liter is going to be 10 centimeters by 10 centimeters by 10 centimeters. So imagine a small box that's 10 centimeters by 10 by 10. That's 1 liter, and then the volume of air contained is going to be 22.5 liters under 1 atmosphere of pressure and at 0 degrees Celsius. So we call this the standard volume in chemistry. Okay, let's take a break, and when we come back, we're going to switch gears and we're going to talk about kinetic theory.